You know, everything moves, and we've been learning about some measurements that we can make with respect to motion, such as distance and displacement, speed, velocity, and acceleration. Well, today, what we are going to do is start learning about some causes of motion. What makes those things move? So, specifically, we're turning our attention to forces. Now, force is any push or pull. What a force is, I guess officially defined as, is an attempt to change the motion of an object or its form. Now, when I say attempt, it's because forces can act on the same object at the same time, and they can oppose each other. So only if one force is greater than another will there be any kind of actual movement or some sort of change. So we're going to learn that forces are vector quantities, and so they can be added, and you can do calculations with them just like you can the other measurements and variables that we've been learning about. Now, I'm not going to go into great detail today all about forces, but you can generally categorize them into two broad categories. There are what we call contact forces, and then there are forces at a distance, or action at a distance forces. So a contact force is exactly what it sounds like. In order to push or pull something, you have to actually touch it. So, for example, when I was typing out my little notes this morning, I was touching my keypad and I was forcing the keys down in order to make words on the screen. So that's an actual contact force because my fingers had to actually push down on something. But there are also these action at a distance or forces at a distance, the things that don't have to necessarily be touching. Things like gravity or magnetism. Gravity, for example, if I stepped off the side of a cliff, gravity would pull me straight down, even though I'm not touching the earth. While I'm sitting here on my chair, gravity is still pulling me straight down, even though I am touching the earth, or at least I'm touching the floor. So things like gravity and magnetism can work at a distance, or they can work in contact either way. Now, the distinction between those two things is not really all that important. I just bring up this fact because gravity is actually a very interesting force and one of the first ones that we want to deal with. Even though it doesn't have to touch something, it can have an action on something. So I'm going to talk about gravity as one of the main topics over the next few weeks. And what I want to do today is just introduce you to a new project. So this is like the Hoop Glider project, only it's our next mastery grade. So what you're going to do basically is roll objects down a ramp, and gravity is going to be the force that causes those things to move down the ramp. So we're going to investigate gravity as a force. And what I want you to do is just try to figure out for yourself, without me telling you, without having to read about it somewhere, the relationship between different size forces on different masses of objects, as well as the resulting acceleration when a net force is applied. So we're looking at relationships between force, mass, and acceleration. Three things that we could measure, three things that can vary. We're going to look at these relationships mathematically by doing some calculations and graphically. So that's one reason why I started teaching you about reading graphs. Now, I've made a video that gives an overview of the project. It gives sort of a broad outline and gives some various possibilities for what you can use to build the ramp with. I want you to scrounge around at your house and see what you have to use. I've also posted a set of written instructions that gives basic guidance on 3 sets of experiments that we are going to do with the ramp. So This is all under the homework section of the classwork tab.